Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm your host, Michael Burke, and I'm joined by my co host,
Ben Wilson.
And today we do not have a guest, which is very sad. But frankly, I'm ready to get down on a panelist episode and talk about something that I'm wildly underqualified to talk about. Ben will explain his experience with this stuff as well. But yeah, what we're going to be talking about today is God. Long pause. So in like the recent ML world, ChatGPT has sort of shaken up what a lot of people think ML can do, and everybody's like, oh my god, is artificial general intelligence here? Is Terminator coming? We got self-driving cars, we got all this amazing technology that's AI driven. And so last week Ben and I were just talking about AI and God is like a relevant topic right now. So we're going to get into that and hopefully not offend anyone. But if we do, apologize. So yeah, sound good to you, Ben?
Yeah, and to preface this, maybe we shouldn't use the term God, because that has connotations with actual religion in the world today. What if we just use the term the divine? And what we refer to there is not so much organized religion, because we're not going to be touching that, but more the concept of what was humanity 15, 20,000 years ago when they were living on the plains of North Africa and, figuring out how to master the creation of fire and create pottery and early cave paintings, and the concept of the stuff that we've discovered of people wanting to record for their own culture's sake of history. Like some of these cave paintings you see, there's pictures of certain types of animals, there's pictures of humans standing around fires, pictures of hunting, pictures of meteorological events. There's things that are of a nature of awe that they consider them divine. Like, why do the herds come at this time of year? Why are we able to hunt now but can't at this other time of the year? Why do the rains come? Why do things grow at certain times of the year? Why is it that when we look out at this certain point in the horizon, the sun rises at this exact time, at this exact place every single year? That seems like there's an outside force that's doing that. And that's what we mean by the divine or God, is people attributed that to an outside force that is beyond their comprehension. We no longer do that. We know what the solstices are. We know what animal migration patterns are. We know about the seasons. We have data that explains all of that. So it's no longer a mystery. We don't worship a sun god anymore.
Yeah, and to be clear, that it makes a lot of sense why people do that. I find the Big Bang pretty freaking unsatisfying. Like time started there. Well, what was there before? How can there be something out of nothing? Like, and as a human, I find that that's fundamentally a difficult concept to accept.
Mm-hmm.
But I think patience, either like you can attribute it to God, 100% a valid approach, but also being patient and humble and saying, well, maybe we just don't know yet. That's the opinion that I subscribe to, and it's proven itself throughout history. But who am I to say?
And the thing that brought this up last week was after our recording, where we just sat for like a half an hour chatting about this. And what was it that we were saying? I think did we quote Arthur C. Clarke, where like any sufficiently advanced technology is indistinguishable from God? Yep. And we were talking about the history of humanity, about how theology started, this worship of the mysterious, and attributing somebody's got to be in control, because if nobody's in control, what does that mean? That chaos reigns? Turns out that a lot of that is true. Like, why did this flood happen? Why did this tornado come through and rip through our village? Why did my cousin die while fighting a wild boar? Well, if it is just pure chaos and chance, which we now know that stuff is, we could debate like, oh, you could, a butterfly flapped its wings in Java, which caused, differences in air currents and stuff and created this hurricane. Yeah, we could talk about chaos theory like that, I guess, but I don't want to. But when you're talking about not understanding something and having, chaotic situations rule events, it's like you said, it's very unsettling. Like, we become powerless. So as a defense against that, we can say, no, there's something out there that it just needs sacrifices from us, whether that's fealty, whether that's, sacrificing animals like they did back in the day, or dancing around a campfire and praying for rain, or singing for rain. And people believed at that time that that was how you made that happen, or it increased the chances of that. We now know that it's got nothing to do with it. But then,
Probably.
but
I
then
don't
the
know.
the Arthur C. Clarke thing is, have we as a species and a culture descended this slope of uncertainty, of not understanding why things happen, to a point where there's enough people and enough scientific understanding where we say, now we have a lot of stuff kind of figured out. And as humanity has gone down that slope over millennia, you have fewer and fewer people that believe in a higher power, believe in the divine. And now there's people who are, straight up atheists. They're like, no, I don't believe in any of that. I believe in science. But what happens when those people get exposed to something that they no longer understand, or that they're incapable of understanding? Do we have a new, a divine that gets created?
Yeah, so that sets up the rest of this podcast. But before we get into it, I just wanted to quickly define some topics. And this is going to be, again, very non technical, and hopefully it'll be fun. That's always the goal. But it should also provide some context about a lot of the societal and clickbait issues that are currently present. And so let's sort of define some of the core things in the machine learning world. So starting off with artificial intelligence, Ben, what is that?
Complete misnomer, blanket term for marketing purposes that encompasses everything from basic statistical analysis all the way to ludicrously hard to comprehend scale large language models, such as the parent of the big hype right now, ChatGPT, Da Vinci, something that I don't know. I can't remember how long it took them to train that thing, but it was many, many months on a lot of hardware. And they've been working on it for years. So AI as a general term is, when I hear it spoken by lay people, I know that, okay, they're talking about something that computers are doing that is not a human interacting directly with the computer to make a decision. And it's just this blanket term. When I hear practitioners use it, I kind of cringe a little bit. I'm just like, what do you mean AI? I mean, usually it's a marketing term that people are using. But specificity is where you actually want to know, like, well, what are you talking about? What type of our next topic or our next title is usually what I ask.
Yeah, so and I think artificial intelligence initially stemmed from a valid definition or a valid concept, which is this concept of general artificial intelligence. So
Mm,
something that has almost human like intelligence that can make decisions, think critically, do its own thing. And frankly, nothing out there can do that.
correct.
That I'm aware of. Maybe somewhere deep in a military basement, there's an AI, but nothing available to the public that I'm aware of. So that brings us into the second topic, which is sort of this more tangible and specific definition called machine learning. Ben, what's machine learning?
It's another blanket term, but it's a little bit more specific, and it's the idea of using data to train an algorithm that can make inferences about novel data that's given to it. And this topic, or this concept, is used in every industry on the planet. it's something that, I mean, arguably we do as well every single day as humans. We're making inferences about things. We're collecting data about our environment or about things that are going on. We're making micro predictions. Like, hey, I'm driving down the road at 50 miles an hour. Somebody swerves into my lane. Uh, I see that 500 feet out. I know I should turn my wheel to move away from that. You're making a prediction or an inference. You're inferring that your car is going to smash into this other car. So that data that we're receiving is similar to what we can do with statistical models, where we can say we have a bunch of historical events that have happened, or data that we're controlling how it's going to go into this algorithm. We train it, and we make sure that we have a ground truth, or for supervised learning, which is the vast majority of the things that are out there. And it'll adapt and it'll optimize itself to minimize the error in prediction against known historic data. And then we just use it against data that we don't know the answer to yet and act on those inferences.
Got it. So, sort of to summarize, AI is sort of a blanket marketing term that encompasses a lot of different things. And then machine learning is a more specific set of algorithms that usually looks to fill in missing data, whether it be supervised or unsupervised. Is there anything sort of that you have seen brought into the machine learning definition that actually isn't machine learning?
Sure. I've heard people refer to something like statistical models, where you're building like a simple regression. You're just fitting a line basically on the data, and then people saying, "Well, that's ML." It's like, not really. It's just a statistical model. You're just using basic algebra, and you're minimizing the error between the fit line and the data, and you're just recording what that regression equation is. Which is different than generalized linear regression, which I would classify that as machine learning, because you have to have training data and test data, and it's iterating through and constructing a more robust model generally. And then also stuff that I would classify as business intelligence and analytics. I've seen people call that ML, where somebody's plotting a Pareto curve based on data and finding where outliers happen. They're like, oh, we need to look into this data here and see what's going on. It's not ML. It's using statistics. ML also uses statistics, but it's not something that the machine is autonomously doing. You're just feeding data and saying, analyze this and tell me what the relationship is here. So I do see that quite a bit, but not with practitioners generally. I've never heard a statistician be like, "Oh yeah, I'm doing ML with this." They're usually like, "No, I'm just using statistics, basic stuff." Sometimes it's super advanced, but it's not machine learning.
Yeah, same here. And so now that we have those definitions out of the way, let us continue to the first topic, which is pretty freaking mind blowing, and that is the Turing test is complete. Mm-hmm. It has been like blown out of the water by ChatGPT. I've been playing around with it, and it writes better English than me, being totally honest. Its grammar is clean. Its logical sentence structure is clean. It's concise yet thorough. I definitely could not differentiate it from a human. So Ben, what are your thoughts? Is this AI?
No, it's clever. I'll give it that. It does certain things in such a way that it's easy to. It meets the criteria for the Turing test, definitely, but it exceeds the criteria in so many different ways that it's far too easy to tell that this is an algorithm that's generating stuff. So to take your example that you just gave, it writes more concise, better English than I do. I would 100% agree with that for the vast majority of people on this planet that speak English. It is really good. However, I can tell it to modify how it's writing English. I can tell it to give me an answer about a general topic and then say, I want this written in a way that would be good for Twitter. And it'll rewrite it. And it looks legit. It looks like a human wrote a tweet on this exact topic. And then I can say, I want you to write a short form post for LinkedIn for me. This is what a typical LinkedIn post looks like. It'll rewrite it. Not a single grammar flaw. And the topic is correct. It looks legitimate. And then I can tell it, hey, I want you to write a long form essay on this topic. And I want at least 7 pages. And I want you to delve into these technical terms. And I want you to write it in a white paper format. It'll do that. But it'll do all of those things in seconds. And it can adapt. And you can say, I want you to write it in a different style. I want you to write this as an argumentative statement, or I want you to write this as reference material. It'll rewrite that stuff in, half a second. No human on the planet can do that. So it's very easy to be like, all right, this is pretty clever. There are flaws, of course, which I'm sure we're going to get into here in a minute.
Yeah. So then, why is this not artificial intelligence? It can looks like a human, talks like a human. It can seemingly think critically. It can learn. What's missing?
I mean, it is AI. It's not GA. It's not general intelligence. So if this bot or its parent Da Vinci were actually general artificial intelligence, it would be able to do things that we can do. We can just natively do. If it was a super intelligence, it should be better at everything that I'm good at. It's not. And that was what we were discussing before we started recording was if I take a topic and interact with this LLM that I don't know a ton about, which honestly, that's why most people would be interacting with stuff like this. It's why they're putting them into search engines, because they're great at this. If you just have cursory knowledge about something, or you want to learn more about some topic that you don't know a lot about, it presents the illusion of a super intelligent person who knows a lot about this thing. However, if you start asking it deep details about things that you know an exceptional amount of information about and have life experience about this topic, assuming that it's, something that it could have been trained on. So it's got to be about, knowledge that can be written down. So the first thing that I tried to do with that was, of course, try to get it to write some unit tests for me. Not that I'm that lazy of a developer, but I was just curious. Just finished writing a function. I had the chat window open. I was like, I wonder if this thing could actually write a pretty good unit test, because I've written 17 of them so far today. And I wonder if it can just write this one real quick. So I asked it to do it, and I looked at the output and I'm like, damn, bro, like that's not right. So, and I just told it that. I was like, I don't think that's correct. What you're actually testing here is something that it's always going to fail. So why are you expecting to catch an exception that's always going to throw based on what you just told it to do? And it responded in a very polite way. It was like, I'm very sorry. You're right. I'm going to rewrite that for you. And it rewrote it, and it like adapted, and it got it correct. And I looked at it, what it had generated, and I'm like, actually, why did it use a for loop here? Like, why didn't it just use a comprehension? And I told it that. I was like, the runtime of this would be much faster if you used a list comprehension here in Python instead of a for loop. It responds back, hey, you're completely correct. Let me fix that for you. And it rewrote it. And I was like, yeah, that's exactly how I wrote this. Because I wrote it before I started asking it, and it matched. I mean, the variable naming wasn't the same, but then I got it to fix that too. I was like, I don't like abbreviations in my variable names. Can you write them out? And it wrote it, and it was character for character a match to what I had written for the code base. I was like, that's awesome. And then I asked it, I was like, can you make this even more efficient? and it went and generated something that it took me about 5 minutes to look through what it had generated to understand what the heck it created. Because it created something that used 4 separate partial functions that were all defined, nested within one another. And the way that it was written was not intuitive to like how I would expect a test to be written. And it was just really complex code. But I had asked it, can you make this run faster? Copied the code, ran it in a time it, tested it 10,000 times. It was 40% faster than what I had written. There's no way that's ending up in the code base because nobody can read it, but it's pretty clever. It can do stuff like that. So with stuff that you have a pretty good understanding of, you can kind of coax it into generating cool stuff that is useful. And then when you send it the next thing that you want it to do, it's pretty accurate with that, and it maintains that context pretty well. But when you tell it to do something that it's not aware of, or there's no way for it to have collected data on to learn the associations, and I use the term learn loosely here. It's not learning anything. It's just creating the associations in its neural network. You can start pushing it into places where it starts falling apart. And if you push it hard enough, it'll just abort your chat session and the session's closed. So I've broken it a couple dozen times, and I know a lot of other people have as well, where it's just like, I don't know how to respond to this, and then it just shuts down your session. Because it's probably just timed out. It was looking up an appropriate answer and just couldn't, it sort of deadlocked itself.
So you said it's not actually learning. It's just adding associations in its neural network. What is learning then?
Learning of knowledge is exactly that. It's learning facts and understanding their relationships to one another. But true learning is understanding from a historical context what the repercussions are of your misapplication of knowledge.
Yeah, that's fascinating. So what you're saying is that we can have essentially a data representation that encompasses stuff, but what it cannot do is then use those stuffs as first principles and logically apply next steps. So if this, then that. Is that what you're saying?
I think it can, based on what I've tested, it does that pretty darn well. What it doesn't do well, and I don't know if there's an answer for this in current deep learning architectures, it doesn't have fear because it doesn't have an ego. And even people that claim to be egoless, that are experts in things, you do have an id, an ego, and a superego that are all vying for you wanting to become a member of your community. That doesn't mean the community where you live. It means the community of your peers. Nobody wants to be seen as an idiot who's considered to be an expert. So you have this frontal part of your brain that's acting as a filter of the knowledge that you have, the associations that you have, and it basically knows when to interject if you're about to say something really stupid or ask a really stupid question or just present something that's completely wrong. You don't have an intuition of how wrong it might be. And if you push these large language models enough, they'll keep on giving you incorrect answers. You can correct them and they adapt and they start getting a little bit better. But there's no human factor, like human intelligence factor that's in there about, like, to give you an example, if you and I were working on a project and I was your mentor for that project and I asked you to come up with the design of how to build something and your first pass is just utter garbage. Understandable. Like that happens quite a bit when you're working on something complicated. And if I give you feedback that's like, hey, you really should have thought this through a little bit better, like think about these 37 things, and I want you to spend some more time to really think about that. What do you think your response is going to be the next project that we work on together? You're not going to get
Hopefully,
37 comments from
yeah.
me of, hey, you really didn't think this through. That thing is going to be, you'll get 2 comments maybe, because you've learned that and that affected your ego. You felt, whether you felt it in a positive way of like, hey, I'm learning something, I'm growing, I'm getting better. Your subconscious is like, damn, I'm such an idiot. Like, I really screwed that up. I'm not going to, that's not going to happen again. So that's a nature of our intelligence as humans, is to have that desire for community, and that makes us create fewer errors as time goes on of a particular thing that we're supposed to be good at.
Yeah, that makes a lot of sense. So basically, we might have sort of the knowledge framework, but we don't have these external motivators to
Right.
influence how that knowledge framework is used. That makes a lot of sense. Yeah, and I'm reading a book about. I swear I'm not a nerd at all, but I'm reading a book about how it is more statistically likely that we don't see reality through our eyes than we do. Like, it is evolutionarily advantageous to not see reality for exactly what it is. And we can
Yeah.
get into those arguments, but
I,
there's an example of emotions and how they can perpetuate the life of a species or an organism. And so they're like a loss function that perpetuates having more of that same organism.
mhm.
So should we just run ChatGPT through a genetic algorithm and call it a day?
um, I don't know how many compute resources are available to do something like that. Because if it takes 6 months to train it on, I don't know how many tens of thousands of GPUs that thing used. Um, that generative or genetic algorithm, how many epochs do we run? 100,000? A million? We might get a really good trained model with that feedback built into it uh, sometime by 2080. You know, that's the real risk of these things. Like, yeah, we can make it better and we can make it smarter and have it respond better to this, but the efficiency of the structure of the computation of fitting needs to improve in order for extreme improvements to these models, which there's loads of people in universities working on this problem right now. Some incredibly intelligent people are trying to solve this and have been solving it continuously over the last 50 years about how can we make structures of these things. Because everybody's talking about Chat GPT right now. This is not some new thing. Like, deep learning, that goes way, way back, 1960s. Um, but researchers have been trying and failing and succeeding to make new structures and new ways of computing, loss functions across, iterations, and what are the weights that need to share? What is the structure of that neural network? But I still think we're a long, long, long way off from creating something that we would be able to look at as an expert and start asking it questions and get expert responses back and have an actual true dialogue with this thing, whatever it may be. Right now, you can't really do that. I can't be working on a problem for software implementation and have a dialogue with it where I'm getting something back. It's a novelty for me, and I think it's fun and cool, and I'm all for it. But I can't ask it the questions that I would ask you. Like, hey, man, I'm kind of stuck on this problem. Like, what's the best way that I can, compress this JSON and make sure that I can send it over the wire and then decompress it? And, I'm just stuck on this design, part of it. I can ask really abstract questions about something that it should have logical understanding of, and it doesn't know how to respond. I have to teach it over the period of many hours to get that one session to be just marginally useful, because it's not creative. It's not truly thinking about stuff. It's regurgitating knowledge.
How do you define creativity?
Sort of novel thought that is not grounded in a direct knowledge-based answer. It's the thing that sets us apart from computers and from any ML or, blanket AI term. Humans can do that. Computers cannot. I don't care what algorithm you talk about. It's not capable of doing it. They can't. Computers can play classical music. They can't play jazz. Humans can play jazz. So it's improvisation. It's using your intuition based on your knowledge and filling in the gaps and saying, I've never seen this problem before. I have no real context for what the correct answer is for this thing, but I'm going to take some guesses. And the more deep your knowledge is in that subject, the more educated that guess is, and the higher the probability that it is a viable. Is it the most efficient answer? Probably not, but it'll be a viable solution that you could test.
So I will personally give you a Nobel Prize if you answer this. What is the data structure for intuition?
The data structure for intuition.
And just elaborating a little bit. So we have, let's say, a binary representation of a graph structure, and that corresponds to quote unquote knowledge. That's sort of what a deep learning model would encompass.
I mean, it's a qubit. It's a non-binary state is intuition. So we don't have, a 0 or a 1 in there. We have all possible values between 0 and 1. It's just a continuous, threshold of values that we can say, all right, I think localization is going to be somewhere around 0.011623. And we're able to hone in on what a possible solution would be for that intuitive thought based on a gradient, not based on binary. That's why when people have talked to me about this before, I've always sort of said, like, I don't think silicon's the way to go to get general intelligence, because we don't think, our brains are, to a certain degree, binary structures, but the connections between them in our own personal neural net is far more complex than anything you can do with silicon-based CPUs or GPUs.
So my understanding was that neurons are binary. They either fire or they don't.
Mm-hmm.
What do you mean by continuous or cubic versus binary?
We're not talking about individual neurons, though. We're talking about not random, but collections of them that are mutable. So we might take these 17 that are part of this one concept, and the combination of their signals on an output would lead us to imaginary thought of that potential condition. But in that process of thinking that through, how many clusters and groups of neurons and different configurations are we doing? So instead of a deep learning neural network where you're just passing from phase to phase, or transiting a graph of fixed position entities that you can switch on and off these different things and provide weights to what their impact is to the next consecutive layer. I think our brains are far more complex than that, like orders of magnitude more complex.
Interesting. Yeah, I remember a couple months ago we had a guest that specialized in artificial general intelligence, and he mentioned that the brain only has about 10 billion neurons. Mm-hmm. And so we have the compute power to represent that right now on a not that powerful chip. So it sounds like it's sort of the 3D structure that we're missing. Because I still don't quite understand the difference between like if we can recreate a neuron structure in our brains. Why is that not sufficient to have sort of intuition?
Why is it that when we put those awesome hats on people's heads and have them think about certain different things or do different things, all these different regions start lighting up to different levels? Like, hey, this person is thinking about their favorite food, or they see a picture of their favorite food, and you get this one center of the brain that lights up quite a bit, and then something that they just kind of like as a food, and it's sort of the same area, but the shape is slightly different and the intensity is much lower. How does that work? And we're just measuring the electrical signals from the neurons activating. We're not an electrical entity. We're not using electrons entirely. There's chemistry involved, a lot of complex chemistry. I don't think that we understand how brains work quite yet. Not as well as we as a species think we do.
Cool.
I think that research is still active, and it will be for a very long time.
Got it. Well, I'll give you half of a Nobel Prize for that answer, but sounds good. Cool. So moving on, I had another topic that I wanted to chat about, which is a quote from Nick Bostrom, which states, "General AI is the last invention that humanity will ever need to make." What are your thoughts on that?
I don't agree. For a number of different reasons. The first superficial cursory reason is the doomsayer interpretation of that, where like, hey, it may be the last thing that we need to invent, and then it may be the last thing that we invent. Ha ha ha. I don't believe in that. I don't think that's going to be a thing that happens. That could happen many thousands of years later. And if humanity approaches the generation of something like that in a really stupid way, that could happen. But I don't know. I guess I'm a humanist. I work with technology, but I believe in humans far more. And I believe in the spirit of humanity. If you look at history and what we not just as individuals, but as a culture, as a species on this planet, where we've come in such a geologically short period of time, from evolving from our last known ancestor, and then mixing with several other hominids throughout the world, and we've created this species that's able to go from living in trees and foraging for rotting carcasses in the jungle or on the prairies and picking berries, and we've learned how to do everything from animal domestication to crop domestication to the concept of thinking through how things could go poorly. So in nature, so we start storing food, which allows us to create cities and creates all of these other aspects of that. Not all of them great, but it's something that is almost if you look at it at a large enough time scale, we're on this direction as a species of continuing to expand and making it so that we can have specialization of tasks, so that individuals can hone in on very specific problems that we're trying to solve as a species. And where is that going to take us in the next 1,000 years? Where is it going to take us in the next 100,000 years? Who knows? But our advancements in a lot of different ways are, if we're talking about technological advancements, we've done quite a bit in a short period of time. Like we're flying to our nearest stellar bodies, sending people back for the second time, our second group of time. We're talking about colonizing another planet in our system. That's quite a bit of progress. And that isn't because we stuck with what we're good at. If we just stuck with what we're good at, we'd be really good stewards of the land, I think. We would be, our climate wouldn't be in a problem right now. We'd learn how to live harmoniously as we probably did for thousands and thousands of years, but becoming more efficient at doing certain things. So maybe there certainly wouldn't be as many people on the planet. But if we just stuck with what we were good at, we'd have like really good spears and really good bows and arrows, and everybody would be really efficient at making fires. But we don't do that. We adapt. We're creative. Uh, we use our intuition to try new things. Sometimes they're stupid. Sometimes they're amazing. Sometimes they're paradigm shifters for us as an entire global species, for better or worse. So the idea that general intelligence is the last thing we'll have to build, I don't buy it. It's the same argument that people used about, the horse in the car. Everybody's freaking out, like, oh my God, this new horseless carriage is coming. Like, what are we gonna do with all of our horses? Um, there's just not as many horses around anymore. And they're certainly not, being used to pull farm implements and wealthy people around cities anymore. Cars are used for that. But people panicked about that and they got really upset. They're like, well, what are we going to do? What are all the people that care for horses going to do? They'll be fine. They found other things to do. Their children did other things. They're not grooms anymore. They're, maybe they went.
They're baristas at Starbucks.
Or they're university professors, or they're working in AI. Humans adapt and we do different things over time. If you look at it a short enough time period, that's when people panic. And it just so happens that that time series is usually 100% aligned to a political election cycle. So in America, that 4-year time gap, everybody talks about things that can be done in that short period of time, and people panic about that because that happens to coincide with the people that everybody are listening to that are on television all the time. They're the ones talking about that stuff. Like, oh, we really need to, think about creating new jobs in the steel industry in Pennsylvania. It's like, really? Do we really need to do that? There's a lot. Like, why don't you take some of that money and retrain these people to do something more productive for society, or just wait a decade or so? They'll figure it out there on their own. Humans are mutable, and they change and adapt, and they're highly creative. So even if there's this super general intelligence that's everywhere, ubiquitous throughout society, and helping us do certain things, humanity will adapt and fill in the gaps. We'll start doing things that it's not like the super general intelligence is going to be doing everything possible ever. And there's going to be this massive shift in existence of like, hey, everything just got built. Everything that's ever been or that ever could be is now done. It's not how reality works. So I think it'll be a useful tool to work with us, and we'll come up with creative ideas, and we might not be going through the painful process of testing that out, which could take years or decades or centuries sometimes. Talk about like drug discovery, like, hey, we need to come up with this new drug that cures this nasty disease. Maybe we tell the super general intelligence, like, can you run a bunch of simulations and figure out what is the most promising thing to do with this? And then turn on that factory that produces, test vaccines. And can you just generate 1,000 of the most promising ones and we'll test it out? And the super general intelligence just puts a big thumbs up on the screen and the factory starts up. I think it's something of that nature would, like, that's where we're going. But how that's done right now is 10,000 humans that went through collectively hundreds of years of schooling in order to figure out how to do that entire process. And it takes 25 years. Like, I think there's better things that people could be doing with their time. I think the people doing that right now would agree as well. They're like, yeah, I'd rather be solving these other problems at the same time. So it's going to be a tool for us as a species.
No, I agree. I think the quote is a bit short-sighted, and I don't think that artificial intelligence, although it's impressively powerful, is much different from a car or any other disruptive technology. Mm-hmm. It will dramatically change jobs. It will dramatically change required skill sets. It will dramatically change even maybe what humans look like. Maybe we don't need to be as strong and carry as many heavy things. But there will be things left for humans to do. For instance, building the AI. It
Mm-hmm.
could build itself, but I think that we should probably have some humans helping out just to make sure it's on the right path. And also art, like Ben said before this call, we were chatting about trying to get ChatGPT to make a musical composition, and it's not amazing at it yet. And I think that one of the fundamental things about being human is those evolutionarily inspired and developed traits that influence how we use this knowledge in our brain. And I maybe art from ChatGPT in 100 years is going to be the best thing ever, but I think fundamentally human art will retain some of its qualities and differentiate itself from AI generated art. So I 100% agree. And then also one more thing, history backs this up super super hard. If we sort of take a dose of humility and say, all right, well, 100 years ago there was a similarly disruptive technology, take the atom bomb, for example, then the nuclear bomb. Everybody thought it was doomsday, and humanity has more or less survived. So I think that AI, while it's impressively powerful, is not going to be that different.
No, it's going to be another tool, and it's going to be a great one. I'm looking forward to it. I mean, maybe we came off as being negative Nancy's on this podcast, but I think we're both pretty big fans of this type of stuff, and I'm excited at what the next iterations will be. I want to see the generation of one of these LLMs 5 generations from now, and then look at it and be like, hey, I'm trying to do this thing. I need a package that does this. And if I can explain in 4 sentences and it can write an entire library for me, that's a big thumbs up from me. So I can move on to doing other things and not do the stuff that just is time consuming and it doesn't really it's things that need to get done, but don't, generate immediate value. And that's where I think we're going to move towards as a species. And that's where we continue to move. Just as you said, like history has proved this out. We're always trying to become more efficient by eliminating the annoying. That's what we do.
Facts. Yep.
Like, why was the car invented? It wasn't, or the bicycle. Why were either of those two technologies invented? Because it sucks walking everywhere, and riding on a horse for 5 hours is painful. I don't know if any listeners have done that. Try taking a ride through the Australian outback for 4 days on the back of a horse, and you tell me how your outback ends up feeling at the end of that. It is painful. So people didn't want to do that. So we create these things of technology that allow us to more efficiently get to the place that we're trying to go. People can really enjoy riding a horse. I like riding horses. I think they're super cool. They're awesome animals. But I'd like to ride one for an hour on a beach or along a trail as recreation and then feed it some apples and carrots at the end. I don't want one, in a building in the back of my house that I have to feed every morning and I have to subject it to pulling things for me constantly. Yeah, cars are great for that, So
Agreed.
yeah, we're constantly becoming more efficient, and that's where I see the creation of these technologies and what they're going to be doing, what they've currently continue to be doing. That's what ML is in general. Think of all the applications that you've ever done in industry or companies that you work with now. You're helping them build things. It's all to automate things. It's to make things simpler. It's to automate away the annoying, and that's what we do, and we'll continue to do that.
Yeah, couldn't have said it better myself. So I'll quickly wrap and let you guys continue on your amazing day. So today we talked about sort of the high level power of artificial intelligence, connected it a little bit to the divine, thought we would go a little bit more into that, but there were some other interesting topics at hand. So to summarize some core things we discussed, AI is essentially a marketing term that includes almost all modeling. General artificial intelligence is this concept of a thinking, feeling being that can make logical decisions. So there's a big difference there, and AI is overused. In general, just don't use the word AI. And then machine learning is a subset of artificial intelligence, which is specifically a set of algorithms where a machine learns often over iterations. But there are also other methods that are sometimes lumped into ML. No need to get into the nitty gritty, but that's generally what ML is. And then finally, ChatGPT is not artificial general intelligence. Sorry to break it to you. It's cool, it's powerful, it's going to probably change the face of a lot of work, and subsequent technologies built on it will definitely change the face of a lot of work. But right now, it is not Terminator.
Definitely not. And it can't write anything but crappy pop songs.
I love crappy pop songs. It's my favorite kind of pop song. All right. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
And have a good day, everyone.
Take it easy. See you next time.